H3 for 105.
True. We are right here. Or in the unoverloaded method, we are right here. We're declaring an int variable. It does not matter what it is called. It's just so that we know that this is going to be our thing that we are going to be returning.
Okay, we're coming back to that. Now waiting for this node to stop doing this and die already. Thanks. Okay. Now I'm gonna block myself in. You guys do it. Oh my god. God damn it. God fucking damn it. Fuck you.
We know it's the thing that we're going to be returning because that's our intent for it.
Oh, okay.
Paired with the same type as the method.
Okay.
Yep.
Okay, sorry about that. I forgot I had a mic on my computer.
All right, good.
Okay.
Okay, so right here, we're going to add in a note for this one.
Static. No object required.
All right, so now that we have our overloaded method complete, we could scroll back down. And we can use the same variable as before, the stored return. And in this case, we can say equals sum, parentheses. And the moment you finish the name of the method and type in the parentheses, because it's overloaded now, we can see both definitions that we've written. So we've given comments for both, basically saying it's static, we don't get an object, its return type is int, so we require ints. The identifier is called sum. In this version right here, we have the non-overloaded version, so number 1, number 2. And the goal is to return sum of two numbers. Now if we click over here, we can now see that we have the overloaded version, number 1, number 2, number 3. We can also see it in the parameter list of the notes for this one as well. You do not, in this language, have to select which version of the method you are attempting to run. Just provide the appropriate number of parameters for what you are trying to do. And then we can copy and paste the output, rebuild it, and then run. And we see the original sum call return 4, and then 1, 2, 3 being the sum of 6. We see stored return 6. Do you have any questions on creating an int method and an overloaded int method? All right, moving on to a void method.
Void method.
Right here, we have a static, so no object reference required, void, no return, line being the name or the identifier of the method, and no parameter list.
Static.
And all this method does
Void.
is it's going to output a bunch of equal signs in the form of a line so we can separate our output basically for readability.
Yeah. And L.
So again, static void line, void, no return, so we don't have a return statement inside of the scope, and all we're doing is outputting a bunch of equals. You can do underscore dashes, does not matter. If you are following along with the example, the purpose of this method is to separate output. So we can come down to where we know output is, and at the end of it, call line. After rebuilding and running, you can see that we have our separator or line method running by it separating all of the output. Another static void method we could do is message.
$115.
So now, if we wanted to output something and have it be separated via lines, notice I'm calling the line method inside of the message method. So we have line, and that's the out for our string parameter message, and another line. So when I go to call that, what it's going to look like is simply the message, and then I call the message, and then we can see line, the string that I wrote, and then another line. So we can kind of see in a very small example the concept of dry, where I'm not going to bother counting out how many times or how many equal signs there are here. just note that we have typed significantly less already, and this is just a one-line method. So instead of, I'm just going to guesstimate like 30 characters there. Anytime that we call line, it's 7 characters, including the semicolon, so significantly less typing or holding down a key. All right, so we've seen
120.
int methods, we've seen void methods. Before I go into classes, I'm going to make a method for a couple other types. So other types,
120.
we can make a method for all types, including programmer defined types, classes E is 7.
All data types.
So, so far we have int and void. And I'm going to move this around. Be under the sum above, under the voids as well. So we're going to say static string reading.
Oh, is the match done? Oh, the match is done. Yes, I'll come back.
And it has a string type, so a string must be returned. So for this example, I think we're just going to do return hello world. If we wanted to overload it, we could have a parameter, a single parameter, doesn't matter how many we have because our initial one has 0, and then we're just going to be returning a message. So before I call
Okay.
call these two, I'm going to put notes on everything that doesn't have notes yet. So we're going to start with message.
Come back to that. No! Come on, bro! Y'all need to stop adding that. Cowards. Yo, teammate, help me. Yo, teammate, help me. Yo, teammate. Yo, teammate. Yo, teammate. Yo, teammate. Yo, teammate. Jesus Christ. Okay, I give up too then. Back to my lecture. greeting 1, overload with no parameter. Greeting overload 2 with 1 parameter, string message. This is static with no void.
Question from online, what do you mean by no object reference? I will show that here in just a moment.
125. Since no void, return 1 value.
Okay, so I've commented out the last 3 methods. We can then call greeting and then the overloaded greeting as well. And after that, I'm going to put some more comments down here
method
and possibly move some stuff. So we're going to do call greeting and then overload greeting.
greeting.
Okay, so now we're going to rebuild and then run, and we'll be able to see hello world and hello user at the bottom. Sure.
And then greeting.
So it's not displaying the from greeting or from overloaded greeting, so we're going to have to go back up here, look at exactly what I did. I did it as returns, not as cout statements. So what we've got to do here is
cout.
put it inside of a cout and see if it works.
Cout.
So now we can see the output from both greeting and the overload greeting at the very bottom. So now for the online question of what do I mean by no object reference? To do that,
Oh, let me pull
put it
back.
inside of a cout and see if it works.
What about this third one?
So now we can see the output from both greeting and the overload greeting at the very bottom. So now for the online question of what do I mean by no object reference? To do that, to show what I mean by that, we're going to have to create a class. This again is going to be day 7 day material, so you don't really need to know it for lab 3. It's just a good thing to understand why static is being used when other methods may not be static then of themselves.
Yo. Alright, I've had enough of you. We're out. Class example outside of int main, outside of method as well, but after essentials. Okay. We're gonna put a code example here. Where did this go? Hashtags. Hashtags. Then we go class. Example. Example. Then we have our squiggly bracket. Then inside the squiggly bracket we put public with colon. Then access modifier inside the code block. The class code block, which has the public access modifier, and within that we have a function called example argument parameters parentheses, then another squiggly bracket going a line down, then std, of course, for what? What are we doing here? We gotta get this up to 25. Finish this page, then we'll have
Again, this section I'm going to make a big note of it.
basically cout string example, and of course end line or standard library colon end L semicolon line. And I put the mysterious mustache brackets. Let's pause this. That ends that example functionality. No void. But then down here, now have. Notice now we have void. Method. Of course, your parameter parentheses. Then go down another line. Void example method. Some method, and of course, come down here. Put another squiggly bracket for a code block. Come down. Cout string. Then end of
Okay.
line.
So what I have here is I have a very small class called example. We have the public keyword, so anything above it's going to be private. We don't have anything above it, but everything below it is going to be accessible outside of this class. So the next thing is we're going to have a specialized method called example that shares the name of the class. It's called a constructor. Again, we don't really need to know this. It just has to be there for what we're doing.
Because it started, we never added in code block for the class example. But we do that after we've done all the coding. This right here. This is called a constructor. Share name with class. It's not static, so I'll do it.
I'm going to
Is void. So not static.
move this comment around so it looks neater. I'm going to rebuild, and it's yelling at me because of class. Actually, it's expecting a semicolon somewhere. Where did I put it? I'm going to clean it, rebuild it, and then so Again, we have class example. We have the specialized method that's going to be required for when we actually go to create an object from this class. And then we have our method void some method. Note that it is not static, and also note how we actually call the method. So again, the class is called example. A note right here is this is an example of a programmer defined type.
Programmer defined type.
Yep.
Class.
And then we're going to scroll all the way back down to the bottom where we are putting our calls. To create an object of a class is class name and then object name.
I'm going to pause here. 126. Next page. Okay. So we'll go page for hour 1 minute 26 second 31. Lecture 30. Okay, so we're over halfway done with this.